Okay, good morning, everybody. Thank you for joining us today from Whiteshell Laboratories. My name is Mike Giardini. I'm a communications officer with Environmental Remediation Management Stakeholder Relations team at Canadian Nuclear Laboratories. Before we get started, I just want to note that I'd like to acknowledge that the site is located on the unceded and unsurrendered territory of the Algonquin and Anishinaabe people, and that the WR1 project is located on Treaty 1 and Treaty 3, as well as the homeland of the Red River Métis. As an organization, CNL recognizes and appreciates the Indigenous people's connection to these places. CNL also recognizes the contributions the First Nations, Métis, Inuit, and other Indigenous peoples have made, both in shaping and strengthening the communities where these projects are situated and to this country as a whole. So today's webinar is to provide you with some information on the history of the Whiteshell site. So we'll start with the presentation, and then we'll open the floor for a Q&A, a typed Q&A, and then we'll answer, obviously, with audio. A few housekeeping details. There is simultaneous interpretation. You can access the session in French and English through the globe icon on the bottom right of your screen. Select the language you would like to hear. Today's session is planned for 1 hour. Presentation will be about half an hour, and then we have the rest of the time for discussion. Please use the Q&A icon to submit your question at any point during the presentation, and we will get to it at the end. And if time is running out and a question comes in late, or we don't get to one, or we have to get more information to help with an answer, we can do it through email afterwards. Note that we will be recording these sessions and posting them on our YouTube channel afterwards. So if you missed something or you want to share with anybody else, note that we will be posting it to YouTube. Usually takes a couple days to get the recording and get it uploaded. If you're having any issues with the chat function or anything, please email ermstakeholder@cnl.ca, and our team will be watching the inbox and we'll try and get you sorted out. So I'll introduce you to our speaker today. It is Randall Swartz. He's the Manager of Licensing and Quality Management. Randall, off to you.
Thanks, Mike. Hello, and thank you for joining the session today. As mentioned, my name is Randall Swartz. I've been with AACL and CNL for over 31 years. I started out as a research engineer and then moved to decommissioning about 15 years ago. Today, I'm the Manager of Licensing and Quality Management, with part of my portfolio being responsible for the land use and end state plan for the Whiteshell site. I'm very excited to talk to you about the history of Whiteshell Laboratories site and a little bit about what's happening now and in the future. Feel free to type in your questions at any time and we will answer them at the end of the presentation. So let's get going. So a little bit about who's who, because of the change to the government owned contractor operated model in 2015. What was Atomic Energy of Canada Limited, the Federal Crown Corporation, became Canadian Nuclear Laboratories, CNL. So we do love our acronyms, and sometimes they're confusing, but bear with us. So CNL is the contractor and managing the Whiteshell site as well as the other AECL sites. I work for CNL, and we are contracted by the Government of Canada for cleaning up the Whiteshell site. Our job is to manage all of AECL's sites, and as I mentioned, to perform decommissioning work and waste management. And at Chalk River, there's also science and technology work as well. So Atomic Energy of Canada, AECL, is the Federal Crown Corporation that owns the sites and is responsible for the liabilities at the sites. CNL and AECL have a contractual relationship called GOCO, as I mentioned, the government-owned contractor-operated model. There's also the CNSC in the nuclear family here. That's the Canadian Nuclear Safety Commission, and they are the independent federal regulator responsible for regulating all nuclear materials in Canada. CNL is able to operate and decommission because we have a license from the CNSC. I mentioned CNL manages several sites. These exist across Canada. Chalk River, which is near Ottawa, is Canada's national lab for the peaceful and innovative application of nuclear technology. Home to the NRU Reactor, which for 60 years produced medical isotopes that diagnosed or treated millions of people annually in over 40 countries around the world. There's also the Port Hope Area Initiative, which is near Toronto, and this is the government's commitment to clean up historic waste associated with radium and uranium processing by the El Dorado Nuclear Company, which was a former Crown Corporation of the Government of Canada. There's also the prototype reactor sites. So Canada built prototype and legacy reactors in Whiteshell, at and near the Chalk River site, at the Bruce Power site northwest of Toronto, and the Gentilly site in Quebec. CNL manages these sites and is in the process of performing decommissioning. There's also the Northern Transportation Route, and CNL manages low-level waste sites in Canada along the Northern Transportation Route. We've successfully completed projects in Ontario, British Columbia, Alberta, and the Northwest Territories. This includes radium mining in the north to historic sites where radium dials were fabricated. And then the last one is the site that I work at, Whiteshell Laboratories, located about 100 kilometers northeast of Winnipeg near the towns of Pinawa and Lac du Bonny. At one point, it was one of Western Canada's largest research facilities. This is what the Whiteshell Laboratory site looks like. And as I mentioned, the site is approximately 100 kilometers northeast of Winnipeg and 10 kilometers west of the town of Pinawa. It is just downstream from the Seven Sisters Hydro Dam and located on the Winnipeg River, which you see in the foreground of this picture, the Winnipeg River. Most of the site is located in Treaty 3 territory, the east side of the river, but has some land on the west side, which is located in Treaty 1 territory. The site is also on the traditional homeland of the Red River Métis. The site covers an area of 4,375 hectares, which is about 11,000 acres. Here you see the main campus looking eastward with, as I said, the Winnipeg River in the foreground. The site is serviced with domestic water, process water, fire water, storm drain, domestic drains and sewers, above and underground electrical distribution, and fiber network distribution. Essentially, the site is a standalone community with security, fire protection, and its own lagoon system, as seen here in the upper left. Other notable facilities included the WR1 reactor, which is housed in Building 100, labeled on the photo here. Building 300, which was the radioisotope laboratory, some of which has been decommissioned, and we'll get to that a little bit later. And Building 200, which was a water collection and treatment facility. Difficult to see in this photograph, off in the foreground, in the background there. There's also a waste management area and a non-nuclear landfill. So a little bit about the past, the history of the Whiteshell site. So why is Whiteshell Laboratories here? It was established in the early 1960s as part of the Government of Canada's nuclear research facilities. At its peak, there were close to 1,400 employees working on the site. The WR1 prototype reactor, shown here on the left, was built to test the concept of using an organic cooled reactor and to test different fuel types and configurations. The Whiteshell site and the nearby underground research laboratory, which is now fully decommissioned, led the development of the deep geological geologic disposal approach for spent nuclear fuel. This garnered collaboration from many countries around the world. Whiteshell also delivered extensive power reactor safety research, including large-scale experimental facilities such as the RD14M thermal hydraulics facility that was a scaled full-height electrical mock-up of a CANDU reactor, and hydrogen facilities for combustion testing and testing of hydrogen recombiners. This was a direct part of my past with AACL as a young researcher, until I moved over into decommissioning, as I mentioned. Other areas included performance studies on materials and components. Overall, Whiteshell contributed extensively to nuclear research in Canada and around the world. Here's an old photo of the WR1 control room and the reactor hall area. Yes, back then you were allowed to smoke in the control room. How times have changed. So almost 60 years ago, in July of 1963, coming up on the 60-year anniversary, the first family moved to Pinawa. The town was built specifically for the employees of AACL, who over the following months and years would be moving to the area to work at the much anticipated new nuclear research station. The photo on the left shows a bike parade from Pinawa's 4th birthday celebration in 1967. Pinawa continues to celebrate its birthday every year in July and will celebrate its 60th in 2023. There was a lot of groundbreaking research that happened at Whiteshell Laboratories. So over the years that the WR1 reactor was in operation, there was lots of research done on reactor safety, lifespans of waste, accident scenarios, and facility that I mentioned earlier, RD14M, which was specifically built to research and test safety systems for the CANDU reactor fleet. And in the right-hand side of this picture is one of the combustion test facilities for hydrogen testing that we had on site. The Underground Research Lab, or URL, conducted countless experiments on deep geological disposal of fuel. Construction of URL began in 1982. It was central to an understanding of the geology and hydrogeology of granitic batholiths, a potential host rock mass used for used fuel disposal, and the geotechnical experiments to support isolation of the used nuclear fuel. And the URL collaborated with numerous countries around the globe that didn't have world-class research facilities like the URL. In 2003, it was decided to close the URL and focus remaining research at other centers. The shaft was capped in 2010. Monitoring equipment was installed to gauge the performance of a shaft seal installed at a fracture zone at 255 meters depth, and the instruments continue to gather valuable data today. So in the mid-1980s, the Government of Canada significantly reduced research funding to AACL, and because of that, AACL decided that it needed to close Whiteshell and consolidate all research at the Chalk River site. Which brings us to the present. CNL's mission at Whiteshell is to fully decommission the site and achieve closure. This is an aggressive plan that is targeting 2027 for completion. This photo shows the main laboratory area back in 2015. That's when the GoCo started. While some decommissioning had occurred prior to the GoCo date, when it was privatized and changed to the GoCo model, it brought international experience in decommissioning to CNL and brought the accelerated decommissioning schedule for the Whiteshell Laboratories as well. This photo shows the decommissioning progress accomplished through to 2022. Over 40 buildings on site have been fully decontaminated and demolished. This includes laboratories, storage buildings, a decontamination center, a water treatment facility, and numerous support buildings. This photo simulates the planned end state of the site. This includes all buildings fully decontaminated and demolished. It assumes the below-grade portion of the reactor is disposed in situ. More on this shortly. All hazardous materials will be recovered and managed, and any contaminated lands remediated. The site will be graded to facilitate surface water management, and institutional controls and monitoring will be implemented. All waste produced will be disposed in licensed facilities where available, or stored until disposal is available. Radioactive waste is being sent to Chalk River in Ontario, where CNL is establishing a low-level waste disposal facility called the NSDF, Near Surface Disposal Facility. In addition to the main laboratory campus, the Whiteshell Labs has a dedicated waste management facility where waste produced on site has been stored since the site was built. This includes two main areas. The concrete canister storage facility on the bottom left of this photo includes 16 above ground storage silos for spent fuel. CNL will be transporting this high level waste to Chalk River for centralized storage until a national repository is sited and built. The other section, simply called the waste management area, contains various waste storage structures that range from low-level clay trenches to concrete bunkers to concrete below-grade silos and other storage methods. The concrete below-grade silos are also known as standpipes. All waste, except most of the trenches, will be recovered, characterized, segregated, packaged, and the waste managed. Most of the trenches, as discussed at the time of the site's comprehensive study report, were identified to remain in situ, pending a final safety case that would need to be accepted by CNSC staff. The waste types and conditions vary greatly, with most, if not all, radioactive waste planned to be shipped to Chalk River for storage and ultimate disposal. Once all waste is removed and waste structures are demolished, any impacted soils will be remediated. Institutional controls and monitoring will be implemented. So now I'd like to discuss a little bit about public outreach and Indigenous engagement. So part of our responsibility in conducting the decommissioning and environmental remediation work at Whiteshell is effective public and Indigenous engagement. CNL works with First Nations in Treaty 1, Treaty 3, and Treaty 5 territory. Our site is also located on the traditional homeland of the Red River Métis. Historically, the relationships with Indigenous nations was weak or non-existent. CNL is working hard to correct this and has ongoing relationship agreements in place that support initiatives such as a community liaison, joint environmental monitoring, and incorporation of traditional knowledge into our programs. The photo here shows members of the Saugeen First Nation Community Liaison Committee touring the WR1 reactor. Here, CNL is exhibiting at a Manitoba Métis Federation annual General Assembly. A Métis monitor is collecting mushrooms on site for analysis. We're collecting groundwater samples from our network of wells and giving a tour to members of Black River and Hollow Water First Nations. Protection of the environment is one of CNL's top commitments and a condition of our license from the CNSC. CNL has an extensive environmental protection and monitoring program. Three main components provide data for the Whiteshell site contaminant pathways monitoring, enabling the monitoring of contaminant levels in the environment. This includes effluent monitoring, both water and air, environmental monitoring, and groundwater monitoring of highly characterized soil and bedrock. CNL is highly transparent about its monitoring results, providing public access to the annual safety reports. The impact by CNL is very small, typically orders of magnitude below threshold levels. Examples of the regular monitoring conducted on and near the Whiteshell site include upstream, downstream, and a site adjacent for river water, sediments, and fish. Surface water in ditches is regularly collected and analyzed. Soil samples on site and from nearby locations, including nearby farms, is analyzed. Garden produce is sampled and analyzed. Wild game that has been killed in road collisions is collected and analyzed, and ambient and background radiation is measured. This represents a subset of the thousands of samples collected annually. Recently, CNL has invited monitors from First Nations and the Manitoba Métis to tag along with our environmental technicians. This has several benefits: relationship building, confidence that CNL is protecting the environment, and CNL is able to adapt our system to incorporate Indigenous knowledge. So a bit about the work that is happening in for decommissioning the site. So decommissioning a building means carefully characterizing it and then removing and managing all waste. Characterization looks for radiation, asbestos, lead, mercury, chemicals, and other hazardous materials. The building is de-energized to make it safe to begin removing hazards. This includes carefully removing drain lines and ventilation equipment that is used to manage contamination. After all hazardous material is removed, packaged, and disposed of or stored, then demolition begins. Building materials such as concrete, wood, insulation, roofing, structural steel, and rebar are all segregated. Often materials, especially metal, is recycled. Others go to landfill or get shipped to Chalk River if contaminated. After demolition is complete, surveys are done to ensure soil is clean. Excavations are backfilled and the area is leveled, and grass is planted or returned to vegetation native to that area. Ultimately, our business is waste management. In conducting the decommissioning and environmental remediation of the Whiteshell site, CNL predicts it will generate close to 5,500 shipments of clean waste, including metal for recycling, 350 shipments of hazardous waste, such as non-radioactively impacted organic material, such as roofing tar, around 2,000 shipments of low-level radioactive waste, and 600 shipments of intermediate level waste. Transportation of waste is safe and very effective. And on this slide, there's some data of our shipments. So a total of 302 shipping loads since 2017, 0 incidents and accidents. I will now give you a deeper dive into what it means to decommission a nuclear facility. The CNL team completed the first major nuclear decommissioning project on the Whiteshell site in 2016. This involved the decontamination, deactivation, and demolition of 85,000 square feet of radionuclide laboratory space. Known as Building 300 on the site, this building housed many labs, workshops, and offices for the multitude of research projects. Constructed in stages from the 1960s to the 1980s, this building presented hazardous materials challenges that were safely overcome. The use of asbestos-containing materials was widespread. Laboratories were equipped with dedicated drainage systems for potential nuclear materials. This network of piping had to be carefully segmented and removed. Over 190 fume hoods were removed and dismantled. All impacted systems were either decontaminated or removed from the facility for waste management. The building contained many energized systems: electrical, air, and water. These were all de-energized to ensure hazardous energy was completely removed. Final clearance surveys were then done to the entire inside and outside of the building the part of the building that was being demolished. Then the big iron went to work, methodically demolishing 2 large stages of building 300, segregating waste and taking it down to the bottom of the crawl space. The cavity was filled with clay backfill, and the end state today is a grassy field, although covered with snow right now. This is a photo of where the WR1 reactor was built and the excavation that occurred when needed for the facility. So WR1 is a pre-CANDU prototype reactor. It was built over the course of 3 years, from 1963 to 1965. WR1 then successfully operated for 20 years from 1965 to 1985 and was safely shut down at the end of its mission. It was designed to test the concept of organic coolant instead of water. This was the reactor was run at a lower pressure and higher temperature than the water cooled reactors at the time. It also tested various fuel materials and configurations. Its nominal thermal output was 60 megawatts, and it never produced any power. It was for research purposes only. There was a robust concrete construction for the facility, and this excavation is for 5 stories below grade. That's how deep the reactor building is, 5 stories deep. So what are the plans for the future? For WR1, the end state is proposed to be a permanent and passive disposal facility, also referred to as in situ disposal. This safely isolates the waste from the environment and people and is achieved by demolishing and disposing of all above ground structures, recycling materials, going to landfill and to the low-level waste facility in Chalk River for any contaminated waste. We will prepare the below grade for grouting by penetrating ducts, tanks, pipes, and cutting holes in floors. And then we will grout the below grade space to provide a stable macro-encapsulated disposal cell. We will fabricate a concrete pad over top to ensure isolation of waste. We will then build an engineered cover system to manage water, animals, and frost. And finally, we would implement institutional controls such as deed restriction, signage, and fencing, as well as post-closure monitoring, which is inspections and well monitoring. The in situ disposal strategy continues to undergo an environmental assessment. Beginning this week and carrying into 2023, we will be engaging the public on the future land use and end state of the site. A telephone poll has started this week. That will be followed up by virtual and in-person open houses and various meetings to gather feedback from people in the area about what the future of the Whiteshell site will look like. So in summary, CNL is conducting one of the largest environmental remediation projects in Canada, located just an hour from Winnipeg. The site and operations are under license by the CNSC, our regulator, with regular inspections conducted. The Government of Canada has committed full funding to remediate this legacy site and effectively decommission to reduce nuclear liabilities. The plan targets complete closure by 2027. CNL, backed by the government, will continue to perform environmental monitoring for an estimated 100 years to verify the predictions of the environmental assessment. Thank you so much for the opportunity to share the amazing work going on at the Whiteshell Laboratories site. I welcome any questions.
All right, thank you, Randall. That was a great presentation. We do have a few questions. So let me pull it up here. First one, in terms of the GOCO contract, so government-owned contractor operated, are there two contractors, CNL and Canadian National Energy Alliance, CNL's owner? And actually, I can take that first,
Sure.
and then Randall, you can add anything if you want. But so we do have this. So this is posted on our About CNL page on cnl.ca. Atomic Energy of Canada Limited has contracted CNL to manage and operate its sites and facilities across the country. It is also contracted to carry out AECL's mandate to enable nuclear science and technology and to protect the environment by fulfilling the Government of Canada's radioactive waste and decommissioning responsibilities. In turn, AECL sets the direction and oversees the contract. While AECL owns the sites and the nuclear liabilities, CNL is responsible for the day-to-day operations and maintenance of the facilities. CNL operates under the GOCO model, and the Government of Canada selected the Canadian National Energy Alliance, a private sector consortium that represents some of the world's most experienced nuclear engineering and management firms to run CNL in 2015 after an international competition. So that is how the GOCO model is run. So again, that is on our About CNL page on cnl.ca. Okay, let me get back to questions. What are the lagoons used for?
The lagoons are used for wastewater from the Whiteshell site.
Okay, quick and easy.
Yep.
Did WR1 ever generate electricity that was either connected to the grid or used on the Whiteshell Labs site?
No, it was not. It was not used for energy producing purposes. It was just used for research.
Okay. In suggesting that CNSC staff will be able to approve in situ disposal of the waste trenches, you mentioned an environmental assessment done years ago. When was that environmental assessment done? Is it still valid? And was in situ disposal specifically authorized by that environmental assessment?
So the environmental assessment was from the early 2000s. That's the comprehensive study report. In there, it identified the potential for in situ disposal of the trenches pending a final safety case. So the environmental assessment is valid and continues to be valid today. And producing a safety case for the trenches is part of the process and part of what was committed to in the comprehensive study report. So that safety case would have to go to the CNSC staff for acceptance before we could leave the trenches in situ.
Okay, perfect. Thank you. You say that shipping nuclear waste is effective. Is this generally true, or is this statement specific to waste at the Whiteshell Labs?
This is across the board. There's a lot of, in terms of the packaging of the waste, there's approvals that need to be done for waste packages and for following the transport regulations for radioactive and other hazardous waste transport.
Yeah, it's highly regulated by the CNSC and both CNSC and Transport Canada.
Yep.
And the industry has been transporting radioactive material for over 45 years by road, rail, water, and air without a single radiological incident. So yeah, it's used all over safely. What is organic coolant? And please describe any hazards that's associated with this type of material.
So I don't know the details, but the organic coolant, it was called HB40, which was used for the organic coolant in the WR1 reactor. I don't have the details on the hazardous, whether it's hazardous or not. We can get back to you on more information if you're interested. You can leave your email in the chat for Mike, or email the ERM stakeholders at cnl.ca for more information on the organic coolant, and that is part of the safety case for the in situ disposal proposed for WR1 as well.
Yeah, we have so the person that asked this question put in anonymous, so we will need to know who you are. So if you want more information, yeah, please ERM stakeholder at cnl.ca, and we'll get that information out to you. Do you have an estimate on how many tons of material from Whiteshell will be sent to Chalk River?
I'm trying to remember. I know we had the number of shipments in the slide presentation. Let me go back to that slide. Okay, that's the past work. I do not have that close at hand. I know that they've got an estimate of, the cubic meters. That's how they have determined the number of shipments, whether they have that in the weight. But again, like the previous question, if you want to know more details, that can be provided through email.
Yep, absolutely. We can get that that information out to you. So the next one is kind of a question about the waste again. So why not dispose the waste on Whiteshell land? Why is the waste coming to Chalk River?
So the waste is going to Chalk River to consolidate the waste that is not to be left in situ at one facility in Canada. The near surface disposal facility is undergoing an environmental assessment presently. That's where the low level waste is to be disposed of. Intermediate and high level waste will be stored until they're at Chalk River site, until there is a permanent disposal facility available, but it's consolidating it in one location as opposed to two locations.
All right. Will the public have an opportunity to comment on the safety case for the in situ disposal of the radioactive waste in the trenches?
We will be engaging the public and Indigenous, and so information about the safety case will be discussed at engagement prior to sending that to the CNSC, just to to update on where the safety case is at. Reviewing the safety case, that I cannot comment on right now.
Okay, thank you. And the next question is about high-level waste and when it's going to be brought to Chalk River, and due to safety and security, we can't discuss the timing and the timing of when shipments are going to Chalk River. It's just simply something we can't discuss with the public due to safety concerns.
Yeah. What we can say is we are planning shipments in 2023.
Okay. So that is the end of the questions. So if a few come in, we'll start to wind down. And if any other questions come up, we will put them in the email that we send out with the recording. So thanks everybody for attending. Let you know before we wrap up that we are interested. If you're interested in learning about anything else, oh, those are different notes. Okay, sorry about that. Okay, so we will send out the links to the recordings, and once they're posted on YouTube, it will take a little bit to get the recording and to post it, but we will include the responses. And again, if we didn't get to anything else or we missed something, please email ermstakeholder@cnl.ca. So, so Randall, thank you for doing this. Really appreciate it. Great presentation, and thank you everybody for attending. And have a nice day.
Thank you. Bye-bye.